Good morning, everyone. Thanks for coming. My name is Sloane Poppei. I'm currently a Master's of Applied Climate student here. This is my last semester, as you're all familiar with. My partners for this project were Allison and Jeremy, and my advisor was Gretchen for this semester. And just going into this, I looked at air quality variability in Detroit, Michigan, and both from insights from satellite and ground observations to get a spatial analysis of what it looks like in this region. So just to set the stage, why Detroit? Well, Detroit has had a rich industrial history, but faces significant environmental challenges in the area. Environmental justice issues persist, which are driven by historical redlining, proximity to industrial zones, and vulnerability to flooding, which Tori touched on in her presentation. On this figure to the right, this is actually drawn from EAGLE, Michigan Eagles Organization. They made an environmental justice screening tool. So what this does is it takes census tract data and combines it with environmental justice scores. Their environmental justice scores from EAGLE's website are actually mostly from air quality issues. So here you can kind of see Detroit in particular has very high environmental justice scores, meaning that their populations are more vulnerable to air quality concerns or environmental justice concerns compared to the rest of Metro Detroit area or the rest of Michigan. And these factors disproportionately affect marginalized communities in the area, especially different neighborhoods on a localized scale in Detroit. So recognizing these challenges, the city of Detroit established a reparations task force. The task force developed recommendations for housing and economic development groups that addressed historical discrimination against marginalized communities in Detroit. This was including but not limited to disparities in environmental quality and health outcomes. This is where the project was kind of brought up to me to look at air quality specifically in the region, and Tori was also looking more at the flooding side of the environmental justice concerns as part of the reparations task force. Now, I'm not working with them directly, but it is heavily inspired by the work from the task force that drives my work in this presentation. So, going into this, why focus on air quality specifically in the region? Well, Detroit, again, has heavy industrial activity and traffic in the area. I'm sure all of you have probably driven through Detroit at one point. There's many, many different highways, many different roadways, and that comes with large amounts of pollutants in the area. And large amounts of pollutants mean high asthma rates and long-term respiratory issues. This figure on the right is actually drawn from Michigan's health database. It just kind of shows a rate per 10,000 population of high asthma in children. What to draw from this figure is that there is just a large distribution of variability in asthma rates throughout Detroit. So that means the air quality issues are highly localized. It's not just all of Detroit, we can say, has bad asthma, but it really depends on the neighborhood you're in and where you're located in the city. And historically, Detroit has struggled with 4 different air quality pollutants in particular that have been monitored and watched by the government. These are SO2, ozone, PM2.5, and also NO2, which I explore later in this presentation. So just my project overview, once again, my objective is to understand spatial and temporal air quality variability in Detroit, and I'm doing this by combining data from ground-based sensors and satellite observations. So starting with the ground-based sensors in Detroit. This figure on your right is actually purple air sensors. So there's 2 different types of ground-based sensors that are kind of brought up and used heavily throughout the nation. So there's privatized air sensors, which includes purple air sensors. These are typically cheaper, much easier to install and maintain. However, they are not maintained nearly as much as the government-regulated air sensors. We can see just overall, this is just a snapshot of this morning, actually. You can get air quality data instantaneously from the purple air sensors on their website. And just notice there's a large variability in where they're located, and there's more of them in different areas. But there is some challenges with this because the purple air sensors do not provide data on they don't provide data on NO2 or ozone, only PM2.5, which was one of the concerns in the Detroit region, but they do not explore the other highly concerned sensors. Now, speaking of which, I focused on more of the government-related ground sensors because those in particular had long temporal data that I could look at and explore to a more high extent. And in addition, they also had information on the SO2 and ozone data. Now, here are some maps that I created to help kind of demonstrate where the EPA and EGLE government sensors are currently in Detroit. Now, these ones on the screen are sensors that look at CO2, and then, where did they go? Okay, and now adding more sensors, these ones look at NO2 in particular. Adding a few more, at the top, we have 2 ozone sensors for the city of Detroit. Oh, excuse me, my slides actually just went to the very end. Let me go back. Spoilers, don't look yet. Okay. All right, okay. Adding an additional sensor for SO2 and adding another sensor here at the bottom that explores PM 2.5. Now, all of these sensors typically look at CO2 and PM 2.5, but some of the sensors are placed more strategically to look at different variables throughout the region. I think most notably, it's interesting that there's only 2 ozone sensors, and I'll show you in a second, but starting with the SO2 values, SO2 is one of the criteria pollutants that was not in attainment for the city of Detroit. Highlighted here is the zone that was considered a non-attainment for this area, and what that means is that the government determined that there was a level of SO2 that was exceeded in this area for this region of time. Now, this zone is in 2018. Currently, the city of Detroit is considered in the OK for SO2, although we are somewhat on the closer side of getting back over the exceedance of SO2 levels. We're simply just under watch for the Detroit area. And then just some temporal look at these sensors. This is just a random amount of sensors I drew from the data to look at SO2 specifically. What to kind of note from these plots is that the red line is the level of non-attainment versus attainment. Generally, you can see that the levels of SO2 concentrations have been below this non-attainment line, which is, we would love to see that, great. But again, it's important to keep an eye on this and make sure that we keep those levels under that non-attainment. And then here we have the ozone non-attainment figure. You will notice that it is covering the entire city of Detroit. So the region of Detroit has been particularly in concern for ozone. We are currently also in attainment for ozone levels, meaning we are okay, given by the government standards. Again, we are in watch, but I think it's most notable due to the fact that we only have 2 ozone sensors to kind of monitor the area for all of this ozone area that was in non-attainment. Oh, sorry. I think I'm pressing the wrong key on my keyboard.
Well, when you're trying to scroll it ahead,
Yeah.
on the tagging, if you go too fast, it thinks you want to complete the thing there.
But here are the plots from the 2 ozone sensors that I drew just for the past 2018 to 2024. We can see there's this attainment line of ozone for the region. Ozone in particular has a more difficult way of assuming whether it's an attainment versus non-attainment. But all of these years were considered to be okay in the clear for the Detroit area. But you can see that there is some seasonal averages, and really looking at summer seasons versus winter seasons is most important when considering ozone for the Detroit region. And here we are, just an overall look again at the sensors in Detroit. You can most notably taking a look back and remembering the purple air sensors. There's a much smaller concentration and variability in where they are located compared to the privatized sensors. And in addition, we are not covering the whole entire area, considering there's many different regions of industrial zones and heavy traffic areas in the city of Detroit. So this is where I kind of entered into another phase of my project in collaboration with the beginning part, looking at satellite data to kind of get an overview of spatially, how are we looking more in Detroit, rather than just relying solely on the ground observations. NASA actually developed a new satellite called Tempo. It launched early last year, and this satellite offers hourly pollutant monitoring across North America. It's a very high resolution compared to its past cousins, you could say. Here on this figure, we have NOM2 satellite and OMI. And here's tempo in comparison. The finer resolution scale really jumps out here compared to the other two. This is a 2x2 kilometer data, so we can get more of a localized look at how things are looking in the city. And we can measure NO2, ozone, and other pollutants to kind of get an understanding of urban air quality in the region. So I took a look at NO2 specifically for this project because its sources include fossil fuel combustion, which vehicles, power plants, industrial sites, all of which are heavily prevalent in the area. And the health impacts of large NO2 can be that it worsens asthma and respiratory conditions, and also forms a role in producing smog and ground level ozone, which were particularly of notable information in Detroit. NO2 is also a key marker for overall air pollution in urban areas, so it's kind of a good idea just to start with the NO2 in my project to get a look at overall what is happening for these seasons. Now, just kind of jumping into the data overview of what I looked at, Tempo has different levels of gridded data. Level 3 gridded data is the one that I took a look at. This is data that provides 2x2 kilometer resolution of NO2 measurements. Particularly, it's going to be a total column concentration NO2. So what that means is it takes the whole column, the whole grid of the troposphere NO2 data. It's not just what they see on the surface, it's the total column concentration, which should relate pretty heavily with what we're seeing at the surface as well. And the focus is going to be on Detroit and southeastern Michigan, occasionally looking at the lower peninsula of Michigan as well, because when looking at 2x2 kilometer data, we need to see the entire picture and not just this localized area to get a sense of what's happening. And since the Tempo satellite is so fresh and new, I looked specifically at summer of 2024 to get a seasonal kind of look at things. As the satellite kind of keeps developing and producing outputs, it'd be exciting to kind of look at the additional seasons as well, but summer is a great place to start. So here's kind of what they currently have on their website. This is actually level 2 gridded data. So what's important to note between the level 2 and the level 3 outputs of the Tempo satellite is that they have different resolutions. The level 2 output has a 2x4 resolution, and the level 3 is a 2x2 resolution. So this is a level 2. You can kind of see that it has more of the finer resolution look to it. This is from June 24th, 2024. You can see that Detroit and Chicago have high levels of this NO2 concentration amounts. And then in comparison, this is a slightly different look, but this is the L3 gridded data. It's kind of difficult to see from this quality of the image on the screen, but you can see that the Great Lakes are kind of present from the Tempo data, but in comparison to the L2 data, there's more of these artifacts, you could probably say, in the data, like these lines and more of a blockiness look to it. So that's kind of something I had to keep in mind and explore as I produce figures and analyzations from the summer. So I started my look by kind of taking a look at daily averages in July. Here's an animation I produced. As you can see, this is southeastern Michigan, and going through the different days of July, starting with July 1st, going to July 31st, you can see that NO2 is highly variable from day to day. This has a lot to do with the meteorology conditions as we go through time. Some days have higher averages than others, around 10 to the 16th for the vertical column total. You'll see there are white parts in the data. That's simply a cloud passing over the region during that day, so there's no averages. And you can kind of see from a local level, you can't really quite pinpoint where things may be coming from just from a day-to-day average, since it's so variable in time. And for reference and ease of knowing where you are, these are just the airports that are local to this region: DTW, the Ann Arbor Airport, Windsor Airport, local Detroit Airport, and as well as the interstate highways. So then I kind of took a look at the monthly and seasonal NO2 averages for the city of Detroit, going through June, July, and August in particular, and then doing a broader seasonal average to highlight the summer air quality patterns that I was seeing with the Tempo satellite. Starting with the June 2024 averages, we have the local Detroit kind of scope of things, then southeastern Michigan, and the Lower Peninsula of Michigan. This will form, I produced the same amount of plots for each month and also the seasonal average. Just kind of taking a look here. So we have, again, the airports on the map, 2 maps here, and on the local Detroit level, we have the Marathon plant, which a lot of local residents find it concerning with the emitting pollutants they have from that region. The Detroit Metropolitan Airport is another area where the key producer of NO2. Detroit Diesel Plant, another large producer of NO2 in combustion pollutants, and then downtown Detroit. So as you can see, the June averages are right on the same scale as the daily averages I had for July, 10 to the 16th. Now, something that is quite interesting is that the city of Detroit has a lot higher concentrations of NO2 compared to the city of Chicago, which I found was quite interesting and something I need to explore further, because you wouldn't maybe expect Detroit to have that high of a concentration compared to the city of Chicago in the corner of my map over here. But again, the pattern kind of lines up to what I expected, with higher values being on the southeastern side of the state, and with a variability in where the concentrations are located in the local scale. Moving into July, the values are a little lower than what was in June. Perhaps there was more cloudy days in this month than there were in the June days. Again, we can kind of see the same similar-ish pattern, although this time the concentrations are more on the lower side of southeastern Michigan and southwest Detroit. This lines up heavily with where the airports are and where most of the industrial zones are in Detroit. So this is something I was pleased to see with the pattern of, and Chicago shows up here on the corner of Lower Peninsula. Moving into August, a similar story. Again, the Detroit region has the higher amounts of pollutants for NO2, and it is a little bit lower than actually the June and July months in terms of concentration at a local level. Again, you can kind of see that meteorology plays a large factor here. There is differences in where we are seeing these high NO2 concentrations from month to month. So moving forward, looking at these different meteorological averages will be important in kind of determining where these NO2 point sources could be. And then here we have the summer seasonal average. Overall, you can kind of see there's interesting blockiness kind of in the data. Perhaps due to working with the L3 gridded data. If you remember me showing you between the L2 and the L3, there's some interesting artifacts here, but also keeping in mind that the seasonal average may have just had large prevailing winds going towards the northeast for the summer. So most of the concentrations of NO2 that were produced in the Detroit Metropolitan Airport area and heavy industrial zones we see in the southwest area of Detroit could be pushing up towards that region of Michigan. And then I also kind of went ahead and did some day-night averages for each of the months and also for the seasonal scope of things, because it makes sense that there may be different variations in combustion pollutants between the day and the night. There's a lot of people traveling to and from work. There's more airport activity between day and evening, and so on. However, there was some interesting things we see in these plots here. We have the day and the night. That will be the same for all the slides. And the definition between day and night is a 6 p.m. Eastern time to 6 a.m. Eastern time between all these graphs. So we can see for the day figure, we have slightly higher values actually compared to the NO2 night values for the June months. And you can see that during the day, there is this similar pattern of prevailing winds to the northeast in the city of Detroit. And in the evening, there's some interesting lines here. Not quite sure if it might be due to the trafficked area or perhaps an artifact from the cloud cover between the different months. And then going into July, similar story with the day-night average. Here we can see that the southwest region of Detroit and southeastern Michigan heavily picks up the NO2 concentrations from those industrial zones and airports. And again, a similar story into August. However, this time into Canada, we actually see large NO2 values during the daytime. And I'm exploring whether or not this would have to do with an event that occurred during the month of August this summer, perhaps there was more wildfires in Canada during that time. And then it's also kind of important to look at NO2 and pollution sources because NO2 levels do highly correlate with the proximity to power plants and major roadways. But it's also kind of important to note that while we can kind of seek out where these hotspots may be, we cannot directly kind of, so to say, put a blame on who's to combusting these NO2 values, as there is differences between the meteorological conditions from day to day. And here, kind of just looking at the month of July in particular for the averages, I have plotted different power plant types that are in Michigan. Here we have, there's only natural gas power plant types in the Detroit region currently. You can kind of see that there are more on the southwest side, meaning that there could be a correlation between those concentrations of power plants and the pattern of NO2 that we are seeing. And then here's the overall Lower Peninsula scope, or to look at it. Again, it's heavily concentrated for NO2 values in the Detroit area, but I would suspect that if the color scale bar was lowered a bit more, you can see that there is another natural gas power plant here that has NO2 values of high concentrations, and again here along the thumb of the state. So there are some limitations and uncertainties to the NO2 plots. The spatial blockiness that we've been seeing kind of creates these blocky artifacts in the 2x2 kilometer data and oversimplifies the fine details. The underrepresentation of Chicago is something that I need to explore more, possibly due to the averaging methods or data sensitivity between each of the months, and also some artifacts in the day-to-night averages. For instance, that one line that may or may not correlate with the highway in Detroit. And also limited temporal scope. The analysis was just restricted to the summer of 2024, and the trends will definitely most likely differ between the different seasons. And kind of tying this back to the implications for Detroit, the vulnerable populations face persistent environmental challenges once again. And so it's important to kind of include these high NO2 areas into the conversation about like higher asthma rates and health risks for these vulnerable populations. And there's definitely policy opportunities here to target pollution hotspots and kind of mitigate transportation and industrial emissions. And then kind of include these conversations where maybe we want more ground sensors or how we can better explore satellite data for the city of Detroit. Some lessons learned throughout this project, I learned to integrate diverse data sources to provide a more comprehensive view of what we were looking at in Detroit. I worked with different data sets. Throughout my time here in Michigan, I have had opportunities to explore using Python, in which I made all these plots with. But working with satellite data and observations was something that was a little bit new to me, and I was very excited to explore that and use it for this project, and also use it in complement to the ground-based modeling. Some future directions with this work, expand analysis to the other seasons as they come out from the satellite, correlate the NO2 trends to possibly health outcomes and demographics in the area, validate the satellite data with the operational ground sensors, kind of do a more two-in-one comparison between the two, and possibly collaborate with policymakers to effectively place new ground-based sensor locations. In conclusion, integrating satellite and ground data highlights Detroit air quality challenges. You can't just get one message from one of the different ways. You need to collaboratively use all your sources to kind of get a big picture story of what's happening in Detroit. And there's this need to kind of emphasize targeted interventions to protect the vulnerable communities of Detroit. And so we cannot leave just the different industrial areas in the story. For Detroit, we kind of need to get that overall general spatial look that the satellite was getting. Because again, there needs to be collaboration between researchers, policymakers, and communities in order to make these decisions come into light. So once again, I want to thank everyone for coming and listening to my presentation. Thank you to both my partners and advisors. And thank you, Tori, for all these years. And thank you to the MEng program for helping me bridge the gap between communities and climate science.